Welcome to the video. My name is Pushpinder Gill, and today we are going to do inequalities for the GMAT. Okay, so we would be mostly covering the GMAT part and taking care of what kind of questions regarding inequalities come in GMAT. So my name is Pushpinder Gill here, and this is my email address where you can send me your valuable feedback. So I've been loving those feedbacks. Let's move ahead and get started with the questions. Now, inequality questions are one of the most feared questions when it comes to GMAT, because you know what, anything can happen. There are so many exceptions, so many things that people generally miss out, and these are those kind of questions which students think they've done it right, but most of the time they're wrong. If they haven't practiced enough, they don't know what they're doing. So it's very important to have yourself ready in inequalities before you actually do some previous some real GMAT questions. So first of all, it's very important to understand the signs which inequality has. So I'm just gonna go through the basics very quickly. So if I say x is greater than y, that means what? That means for x will always be greater than y. That means x can be 5. If x is 5, y has to be less than 5. So y can be 4, 4.9, but it can never touch 5. Similarly, if I say x is less than y, then again, if I say x is 5, that means y will be greater than 5. Right? So greater than means this is greater than, this is less than. Then there's the sign called greater than or equal to. Now what do you mean by greater than or equal to? If I say x is greater than or equal to 5, that means what? That means if x is 5, y can be, if x is 5, x can be 6, x can be 7, x can be 8, and going on. But x cannot be less than 5. Right? So greater than equal to means it can be greater than that value or equal to that value. Similarly, we have less than and equal to. So if I say x is less than or equal to 5, that means x can be equal to 5 or less than 5. Right? So these are the 4 signs which govern the inequalities, and the last sign is definitely equal to sign, which means equal to. So these are the all signs which govern, which rule the inequality. So very important that you know what these signs mean. So this is just the basic part. Let's move forward. Alright, so let's see some of the rules. So I will not be catering to math here. I would be just stating the rules which are very important for the GMAT. So if you're watching this video to improve your math skills, well, you're gonna learn a lot, but not completely. But if you're watching this video for your GMAT or for your GRE, for your CAT examination, this is the place to be. So first of all, when you multiply or divide by a negative, you must flip the sign. Let's say if I say negative 4 is greater than negative 5, everyone agrees with that, isn't it? So if I multiply a negative 1 on both sides, then what will I get? I'll get 4 here and 5 here. Now what's the sign? The sign is reversed. 5 is greater than 4. Similarly, whenever you have an inequality, let's say x upon y is greater than 1, you can't say that x is greater than y, because you don't know whether x is positive or y is positive, x is negative or y is negative. So if you are planning to multiply a variable on both the sides, you should be sure about the sign of this variable. So if this variable is negative, then the sign will flip. If the variable is positive, the sign will remain the same. Let me show you an example. Let me say that minus 3 upon minus 2 is greater than 1. Can I say minus 3 is greater than minus 2? No, I can't, isn't it? Because negative 2 is a negative number. So if I multiply negative 2 on both the sides, I will have to flip this sign. So when you multiply or divide by a negative, you must flip signs, right? So it's very important. I know every one of you would be knowing this, but when you apply to variables, make sure that you know the sign of the variable before you multiply or divide with a variable, right? So let's move to the second point. It says can't multiply unless the sign is known. Again, moving back to the previous example, taking this, I am actually generalizing the fact that if I know that x into y is greater than 5, I can't say that x would be greater than y by 5. This I cannot say unless I know the signs of x and y. So you can't multiply or even divide unless the sign of that variable is known. Similarly, if I say x is greater than 5, I cannot say a into x will be greater than 5 into a. Only if a is positive, isn't it? And a into x will be less than 5 into a if a is negative. Talking about integers only, right? So you cannot multiply or divide unless you know the sign. So if I just simply say ax is greater than 5a, you can't say because you don't know the sign of a here, right? So make sure when you multiply with a variable, you know the sign of the variable. These are the common mistakes that we always do when we do some GMAT questions. Alright, let's see, how do you add inequalities? Now this is very important when it comes to GMAT, because when you're combining both the statements, you're actually putting in some values which you don't have any idea about. So for you to simplify two inequalities, you can very well add them. Now how you're supposed to add them? Now let me show you a simple example. I know that 5 is greater than 3, isn't it? Similarly, I know that 6 is greater than 2. Now whenever the signs of both the inequalities are same, you can add them. 11 is greater than 5. As simple as that. Don't worry about the signs, don't worry about anything. Whenever the sign is same, you can add the inequalities. So if I say x is greater than y and a is greater than b, you can very well say that x plus a is greater than y plus b, right? Similarly, if I say that x plus y is greater than 5 and x minus y is greater than 2, then simply I can add the inequalities because the signs are same. Are you seeing that both are greater than signs? So I can add the inequalities. I can say that x is greater than 7 by 2. Right? So from here I can actually make an idea. So simply I know that x is positive from here by seeing both the inequalities. So whenever the signs are same, you can actually add the inequalities and come down to one inequality which will actually be telling you something about one of the signs. So if you can add the inequalities, can you subtract inequalities? Well, yes you can, but there's a condition here. In case if you want to subtract the inequalities, the signs have to be opposite. Let me show you. If I say negative 5 is greater than negative 6, everyone agrees with that, right? Great. And simply I say 5 is less than, let's say, 7, right? So you can clearly observe these signs are different. Now when you subtract, you're subtracting this from this, so you're gonna keep the sign of the top one. So this is greater than. Now you're subtracting, so the signs reverse. Minus 5 minus 5, that is negative 10. Minus 7 minus 6, that is negative 13. Did I come to a right conclusion? Yes, I did. So whenever you subtract inequalities, you keep the sign of the top one, and both the signs have to be opposite. Let me just show you one more example. Let's say 5 is greater than 2 and 3 is less than, let's say, 8. Now again, you are subtracting the inequalities, so you're gonna keep the sign of the top one. So you say greater than. 5 minus 3 is 2 and 2 minus 8 is negative 6. So again, even if you start with 3 is less than 8 and you say 5 is greater than 2, now you want to subtract. Now you have to keep the sign of the top one, which is less than. 5 minus 3 is negative 2 and 8 minus 2 is 6. Again you get an inequality which is true. So whenever you're planning to subtract inequalities, the signs have to be opposite and you're gonna keep the sign of the top one, right? So in terms of variables, if I say x plus y is greater than 7, similarly negative x plus y is less than 2. So what you can do is you can subtract the inequalities because the signs are different, and similarly you can, when you're subtracting, the signs are going to change, y goes away. You can say again x is, keeping the sign of the top one, greater than 5 by 2. Sorry, x is greater than, x is greater than 5 by 2. Now this will actually give you the general idea whether x is positive, whether x is negative, because it's very important in GMAT questions that you take care of the positive signs. Signs are really important there. The magnitude is not that important. Questions play with signs, positive, negative, right? So this will actually give you the idea of what the nature of numbers is, right? So there are some general traps, especially in the GMAT questions. There are some general traps which will help you to understand what the question is trying to ask me, right? So that you have an idea of what the question is asking you. Let's actually see those traps, right? So if the question is saying x into y is greater than 0, what all possibilities does it come down to? So if I say x into y is greater than 0, then either both are positive or both are negative. One can't be positive, another can't be negative. Both have to be of the same signs. Take an example. 5 into 4 is greater than 0, isn't it? Minus 2 into minus 3 is greater than 0. But if you keep one positive and other negative, that is not greater than 0. So when someone says x into y is greater than 0, that means either both of them are positive or both of them are negative. And if the question asks, is x into y greater than 0, then what do you have to find out? You have to find out whether both are positive or both are negative, right? So that will give yes to your answer. So I'd actually ask you to go through yes no data sufficiency video before you actually try to solve some inequalities questions. So this is a typical yes no data sufficiency statement, right? So let's go ahead and see what the next trap is. Now similarly, if I say x into y is less than 0, that is only possible when one of them is positive and other is negative. It's not possible to have both positive and both negative. Whenever someone says x into y is less than 0, he's just referring to the signs and he's just trying to tell you that one of the x and y's is negative and other is positive, right? So this is what the meaning of the statement, the equality meaning of this statement is. Alright, similarly, if I say x upon y is less than 0, if x upon y is less than 0, again one of them is positive and other is negative, right? Showing that in a division method. So if x upon y is less than 0, one of them is positive and other is negative, right? Great. X upon y is greater than 0, again either both are positive or both are negative. You can clearly observe he's saying x upon y is greater than 0. Either both are positive or both are negative. Now taking the same values, because values don't matter here. What matters are signs, right? So it's the signs that matter, not the values. Okay, now when they say that x upon y is greater than 1, what would you mean by that? Now if I say x upon y is greater than 1, now there are two things involved here. The quality information that you can generate from this is either both are positive and both are negative, or both are negative, and the magnitude of x is greater than the magnitude of y. You say the modulus value. This is what the quality information you can generate out of it. So if I say x upon y is greater than 1, then you're sure either both of them are positive or both of them are negative, and the magnitude of x is greater than the magnitude of y, right? I suppose that's simple, because then only this would be greater than 1, right? And one of them can be positive, another cannot be negative, it's because this, if the number turns out to be negative, it will never be greater than 1. Right? So this is the quality information that you can generate out of it. So you don't have to do that in your exam. You don't have to come up with that. You'll be saving a lot of time, and when you see an inequality question, you should know where to start. You should know what you're doing there. So there are two approaches with which you can do a GMAT inequalities question. One of the ways is completely algebraic way. So what you do is, you have done some basics of algebra in your high school, and you just plan to take that off and do the question using that. And the other approach is using numbers. Numbers really help you to disprove. Again, I would actually ask the students to go back to the yes no data sufficiency video, wherein you'll understand how do we put in numbers and all that, right? So these are the two ways you can do the inequalities questions. Now the problem lies is that you follow only one of the methods. You have to actually take the best out of both the methods if you want to actually survive the inequalities GMAT questions. So don't just go by the algebra, don't just go by the numbers, use both. Now understand the importance of numbers and the importance of algebra. Numbers are going to help you to disprove quickly. So you want to disprove something, numbers are the one which are there, right? Similarly, algebra will help you to prove something. And on the other hand, if you want to prove something, numbers are not going to help you. You want to disprove something, algebra is going to take a whole lot of time for you to disprove that. So make sure you know both the weapons, make sure you apply both the techniques to the question. So what I'm going to do is I'm going to solve some questions, as always has been with my videos. I'm going to solve some questions, and in that journey we're going to learn a lot of things, right? So let's go ahead and see the question. So courtesy to gmatclub.com, wherein I just found out some really good questions, so I would like to discuss those questions. So again, now the question says 6xy is equal to x square y plus 9y. What is the value of xy? Now before you even move to the statements, it's very important for you to bring this to a friendlier zone wherein you can actually extract some quality information out of it. And when I say quality information, means straight away you know what the question is trying to test. Alright, so similarly, if I just rephrase this phrase, I can say x square y plus 9y minus 6xy is equal to 0. Similarly, if I take y common, I get x square plus 6 plus 9 minus 6x is equal to 0. Similarly, if I just try to play with a little bit, I get y into x minus 3 whole square is equal to 0, right? So this is the quality information that I needed. This is the equation that will help me to open the doors to this question. Now, when can this be 0? When can multiplication of two things be 0? Like let's say x into y is equal to 0. What quality information can I get out of it? There are two quality informations that I can get out of it. Is it either x is 0 or y can be any number in the world, or y is 0 and x can be any number in the world, or both are 0? That doesn't bother me as well. So this is the quality information I can get out of if the product of two numbers is equal to 0. So similarly, from here I can take the information that either x is equal to 3 or y is equal to 0. Either one of them is possible or both of them are possible, but at least either one of them is definitely possible, right? So now I move to my statement. What does the first statement tell me? The first statement tells me that y minus x is equal to 3. So now I'm gonna take the help of the numbers to disprove. First attack should be trying to disprove the statement rather than trying to prove it. So how can I disprove? I can disprove really easily with numbers. Now how can I do that? See, y minus x is equal to 3, and I can actually say that x is equal to, let's say, negative 3 and y is equal to 0. So what will be the product? The product would be x into y will give me 0. Does that satisfy the statement? Yes, right? Similarly, I can say that I can keep x to be 3. I'm sorry, x should be here. I can keep x to be 3 and I can take y to be 6. Still it will give me y minus x to be 3, and again still this inequality will hold because I want either one of them to be true. I have got x to be 3, so I can say x into y is 18 now. Since I've got two different values of x into y, that means I cannot be sure what is the answer of x into y. That means my answer is not sufficient from statement number 1. So statement number 1 is insufficient. Let's try statement number 2. Now statement number 2 says that x cube is less than 0. Now you tell me, what quality information can you take out of x cube being less than 0? You are sure that x is negative, isn't it? Now when you're sure that x is negative and these are the only two numbers which you're supposed to give to these values, that means x equal to 3 is completely ruled out. That means I'm definitely sure that y is equal to 0. And when I'm definitely sure that y is equal to 0, I am definitely sure that x into y is equal to 0. And hence statement 2 gives me the answer, and B is my answer. Right? So let me just take a quick recap here. What did we do? We just took a little bit help of algebra here to come down to this so that we can extract a quality information out of it. That quality information was that either x is equal to 3 or y is equal to 0. We used the same thing but in terms of numbers in statement number 1. We actually tried to get x into y equal to 0 one time and x into y and another number one time, keeping this intact. You know, this is the statement which has to be true all the time. Similarly, we went to statement 2. We knew that x, if this has to be true, x has to be positive, but x is negative. That means y has to be equal to 0, and statement 2 gives me the answer. That means B is my answer. I don't need to combine both the statements. If you're worried about data sufficiency here, the rules of data sufficiency, better watch the data sufficiency video, right? Okay. Let's see this question once again. Now you're going to see me doing a little bit of analysis of the statement first and then moving to the questions, right? So first we're going to understand this expression. It's very important that you understand. Don't just randomly put in numbers. Don't just randomly start doing stuff. Just understand, you know, hold off a minute and start understanding this. Now you say that y is equal to modulus of x plus x. Now y is equal to modulus of x plus x. Now remember the first thing that I told you. It's always about signs. It's very rarely about the magnitude of the values. It's always about the signs. So if x is positive here, if x is positive, what can I say? If x is positive, then y is gonna be a number greater than 0, isn't it? Right? And if x is negative, what can I say? If x is negative, then definitely y will be equal to 0. Why it will be equal to 0? Because it will be negative of something plus the positive of the same thing, and that will give me 0, right? And if x is 0 again, if x is 0, that is also going to give me the value of y to be 0. So these are the three possible values that x can take and the two different values that y can take. Now statement number 1 here, tells x is negative. When statement number 1 tells me that x is negative, this clause gets activated. That means definitely I know that y is equal to 0. That means statement 1 gives me the answer. That is this what it's asking? It's asking me, is y equal to 0 or not? I'm sure y is equal to 0. Similarly, statement 2 says that y is less than 1. Now y is less than 1 in which possible case? Now y can never be 1, isn't it? Y can never be a negative number. You can observe here, y can either be a positive number, y can either be equal to 0. Now since I know that y can never be a negative number, the minimum number that y can have is 0, and the key to the question, guys, understand this. The key to the question is y is an integer. Now this is something that we were not putting emphasis on. Now understand that every inequality question is gonna have small bits of information lying here and around, and understand not even one information, not even as small as like x is an integer, or as small as like x is a positive integer, will not be used in the question. If it is there, it is there for a reason. So make sure that you actually, before you go to your answer, make sure that you use that information. Now it says y is an integer. Now the only possibility that would have had that if it was not there, and I would have been disproving this option if x would have been 0 point something, but that is not possible. That means the least possible value of y that is left is 0, the only possible value. That means over here I can again be sure that y is equal to 0. That means statement 1 also gives me the answer, statement 2 also gives me the answer. That means D is my answer option. That is what I'm gonna choose. So let me just take a quick recap. Statement 1 was pretty easy, right? X is a negative number. That means I'm pretty sure that even x is 0 point something, or anything, x is any number, is gonna cancel out and it's gonna become 0. So y is definitely 0 for me. Statement 2 was a bit tricky. It wasn't tricky at all, but you have to actually put an emphasis that y is an integer. You have to be sure there. So y is definitely integer. Y cannot be 1. That means y definitely has to be 0. That's the only possible value left for y, right? So I hope you've understood this. Now you must be getting hang of how to do inequalities question. You gotta do hard work, a lot of hard work on that. Now it says that are x and y both positive or not. It's asking me, are x and y both positive? Now we don't have anything to comprehend from the the universal statement, so we just get along with the option. Now first statement says that x minus y is equal to 1 by 2 or 0.5. Now from here I'm not sure whether both are positive or not. Why? Because x can be, let's say, x can be, let's say, 1, and y can be negative 0.5, y can be plus 0.5. That will give me x minus y to be 1.5. X can be equal to 0.25 and y can be equal to negative 0.25, right? So I get x and y both positive as well, and I get x positive and y negative. That means the statement is not sufficient, right? This is something you should be doing in your mind. This over here, you could write it down as well, but you should be doing it really quickly there. Now x upon y is greater than 1. Now this is a trap. Now remember, we have already discussed when x upon y is greater than 1, what quality information can I take out of it? That magnitude of x is greater than magnitude of y. That means x and y both can be positive and x and y both can be negative, right? X can be 3 and y can be 2, and x can be negative 3 and y can be negative 2, and still these both would hold true, and over here I'll get a different scenario wherein x and y are both positive and x and y are both negative. So that means again individually this statement is not sufficient. Now when you combine both the statements, you know that either both of them are positive or both of them are negative. That means I actually cancel this out. If this has to be true, this will not be true. One being positive, another being negative. Now since both are positive or since both are negative, if both of them over here are negative, that's the scenario which I'm concerned about. Okay, if both of them here are negative, now understand this is a very complex thing to understand. If both of them are negative, and I know that modulus of x is greater than modulus of y, the magnitude of x is greater than magnitude of y, I know that, and both of them are negative. That means this whole number, if both of them are negative, will turn out to be negative, which is not possible because that is equal to 1 by 2. Just try to create a situation in your mind. This is when numbers come in, right? Just let's say x is equal to, let's suppose x is any number, let's say 2. right? And y has to be a number which is definitely less than 2, and in terms of magnitude also it's less than 2. So that means if y is a number which is definitely in terms of magnitude less than 2, let's say what can we say, negative 2.5. Is it possible? It's not possible, because magnitude of y will not be greater than magnitude of x will not be greater than magnitude of y. It has to be between 2 and negative 2. So the maximum possible value I can give is 1.9. And even if I observe here, negative 2 and negative 1.9 gives me a negative number. That means by combining both the statements, I can be sure that x and y both are positive. Hence my answer is answer option C. Right? Let me just take a quick recap here. Disproving statement 1 was not difficult at all. X minus 1 is equal to 1, x minus y is equal to 1 by 2. Both can be positive, one can be positive, other can be negative. I've already discussed x upon y being greater than 1. Either both are positive or both are negative. That means that completely rules out me giving the answer that both are positive. But when you combine both, there are two things, two quality information that you take out of this. That either both of them are positive or both of them are negative, and for sure modulus of x is greater than modulus of y. When modulus of x is greater than modulus of y, x minus y is equal to 1 by 2. Both of them cannot be negative, which is not possible. Why is that? When both of them are negative and the magnitude of this is smaller than this number is gonna turn out to be negative, which is not possible because we're pretty sure that x minus y is a positive number. Then I can say that using both the options, the answer is C. Now you understand that I did not think anything about the magnitude of the values. I was just thinking about the signs, because for me to get x minus y to be 1 by 2 is no big deal. I can pick up any set of numbers, I can do that. So understand that most of the times it's the sign which play a very major role in GMAT inequality questions, right? Okay, great. Let's move forward. Now it says that what is the value of y, right? Now the first statement over here says that y minus 2 is modulus of x square minus 4. You know what, I'm not sure what is the value of x is gonna be, but I should take a hint out of this. It's modulus of something, it's always positive, isn't it? 3 into modulus of something, and when this 2 goes there, it becomes a positive number. That means from here I can say that y is definitely greater than 0. But I don't have any other information. I just know that y is greater than 0. I don't know, because if you say x is equal to 2, y gives me a different value. X equal to 3, y gives me a different value. Want to write it down? You can write it down. You know, you're welcome. But we don't want to waste time here. Now from here, now understand that if modulus of 3 minus y is equal to 11, there are two values of 3 minus y that can come. 3 minus y can be equal to 11, and 3 minus y can be equal to negative 11. So y here can be equal to negative 8, or y here can be equal to 14. So I have two values of y. That means statement 2 is not also sufficient. But when I combine both, you can see these pieces coming together and giving us a big picture. I know that y is greater than 0. That means this option is gone away, and hence this remains the only value of y when I combine both the options, right? So make sure that you use that. Okay, make sure when you got two different values of y from the first statement, can you actually remove one of these values and get one of the other values as the answer? So it was not a difficult question at all, right? But you will have to take care of all the traps and everything, right? Okay, great. Now let's see the next question. It says if x and y are integers, is y greater than 0? Now whenever you read the word integer or distinct, you better mark it down in your subconscious. It says that x and y are integers. It's always good to write it down when it says that something is an integer, so that you know throughout the question. Now it is asking me, is y greater than 0 or not? That means it's pretty much asking me, is y positive or not? Statement number 1. Statement number 1 tells me that x over here is greater than negative 1. Fine by me. It can be greater than negative 1. I don't know anything about y. Statement number 2 it is telling me that x into y is greater than 0. Now what did we discuss about x into y being greater than 0? What did we discuss was either both are positive or both are negative, right? So either both of them are positive or both of them are negative. So from here again, I'm not sure that y is greater than 0 or not. Now if you turn back to statement number 1, now statement number 1 and 2 are individually not sufficient at all. When you turn back to statement number 1, it says x is greater than negative 1. Now what all values x can take? It can take 0, 1, 2 and so on. Now if I see from here, if x into y is greater than 0, x definitely cannot be 0, isn't it? Because that means if x into y is greater than 0, if x is 0, the product is 0, which is not possible at all. So that means the only values for x which are left is 1, 2, 3, 4, 5 and so on. That means by combining both the statements, I can say that x is a number which is positive. Now since if x is positive and x into y is greater than 0, y is also positive. That means by combining both the statements, I can say that yes, y is greater than 0. Now how on earth would you know all this if you hadn't prepared well for inequalities? Now if you didn't know that x into y is greater than 0, the only thing that to look for is either both of them is positive or both of them are negative. That is what thing you should be thinking about. Similarly, x greater than negative 1 should be able to tell you, and you know that x and y are integers. These are the only possible values that x can take, and since you know x into y is greater than 0, one quality information you know that x is not 0, so you can struck out 0, and that means definitely x is positive. If x is positive and the product of x and y is positive, that means y is also positive. That means my answer is C, right? So I hope you've understood this. Let's move on to the next question. Okay, now the next question says that modulus of x plus 2 is equal to modulus of y plus 2. What is the value of x plus y? Now let's try to analyze that, right? So since we have this to analyze, let's actually bring down to some quality information. Modulus of x plus 2 is equal to modulus of y plus 2. Now since again I'm gonna play with signs here, right? So either x and y both can be positive or both can be negative. One can be positive, other can be negative, this can be negative, this can be positive. So I would actually recommend you to make a table like that so that you can keep this information completely organized, right? So that would be a good way to start this question. That'll give you confidence. So here it is. If x is positive and y is positive, that means this 2 and 2 cancel out. That means I can say that x is equal to y, right? And if x is negative, y is negative, that means again I'm sure that a negative number plus 2 is equal to a negative number plus 2. That means again I'm sure that x is equal to y. Now if x is positive, that will make it x plus 2. And y is negative, that means that will make it negative y minus 2, so that they can be equal, and I can be sure that x plus y is equal to something, right? It's actually equal to something. Okay, similarly if one is negative, other is positive, I can be sure that x plus y is equal to something. That will be equal to 4 though, but I don't want to confuse you, you know, how you're gonna get an answer, but it's equal to something, right? So what have we done is we actually analyzed this whole scenario, and we know that what all different values do I need to know. So I need to be sure whether one of them is positive or other is negative, or both are positive or both are negative, right? So let's actually go ahead and see what all information we can get out of there, right? So first of all, x into y is less than 0, which pretty much activates these both clauses, and that means I know that x plus y is equal to some number, and that means I have an answer. You don't need to calculate that answer, you just need to know whether the statement is sufficient or not. That means this statement is sufficient, right? Similarly, second statement, it says x is a number greater than 2 and y is a number lesser than 2. Now x is a number greater than 2 and y is a number lesser than 2. If I actually try and analyze this, right, that modulus of x plus 2 is equal to modulus of y plus 2. That is only possible when y is negative and x is positive. Why is that? See, let's try to analyze. It's all about analyzing, guys. There is nothing like solving here, right? So we just gotta analyze this stuff. Now it says that modulus of x plus 2 is modulus of y plus 2, and x is something which is definitely positive and it's greater than 2. Now since it's greater than 2, that means what? You know, it can be 2 plus 3 plus 2 5, 4 plus 2 6, and for this number to be equal to that, y has to be negative. Let's say if we take x equal to 3, this becomes 5. For this to be 5, I have to take y to be negative 7, isn't it? Let's say I take x equal to 5. 5 plus 2 is 7. That means I have to take y equal to negative 9. So that means I definitely have an answer. Again, I'm sure that one x is positive, that means y is definitely negative. I'm gonna have a definite answer. Again, the statement gives me the answer. My answer option is D. Right? So I hope you've understood. Let me just take a quick recap here again. So what is important here is not what I've done in the question. What is important is the way I'm doing all the previous questions. I'm actually trying to analyze whatever it's there, that information. I'm actually trying to put that into a friendlier information so I can get some quality information out of it, and I can have a yes and a no and a hit target. And similarly, when I move to the answer statements, what do I do is I just go with whatever I have analyzed and see what are the two different answers which I can get. If I can get one specific and a definite answer, that means I'm sure that the statement is sufficient. If I cannot get a definite answer, that means, you know what, this statement is not sufficient at all. So the most important thing in the question is the initial 30 seconds. When you see a question, how do you interpret this equation? And the way you interpret it is pretty much defines how you're going to perform in that question. So you know, sometimes when you're practicing for inequalities, don't just practice questions. Practice how you're going to analyze these type of information. So it's very important. So some people apply this table approach, some people apply coordinate geometry. So that is completely up to you, whichever way you feel good. Now it says that is n negative or not. Let's just move to this question. So what I will do is I will actually recommend you to pause this video and do these questions, right? So yeah, so you can pause it and start doing this question. Now it says n is n negative. You know, you just have to say that n is negative or not. Now it says that statement number 1 says that minus n is equal to modulus of minus n, which is only true if n is either 0, you know, we're going to talk about integers in the beginning, or minus 2 or minus 3 if n is one of these numbers. That means, am I sure n is negative? No, I'm not sure, because yeah, in my set of n there are set of negative numbers, but there is this 0 as well, which is not negative. That means I'm not sure whether n is less than 0 or not, right? That means statement 1 is not sufficient. Statement number 2, it says that n square is equal to 16. Now this says that n square is equal to 16. Now what all different values I can have? Now n can be either 4 or n can be either negative 4. Now either n is 4 or n is negative 4. Is n less than 0? Over here it is not, over here it is. That means again statement 2 is not sufficient. Now if I combine both, I can actually eliminate n equal to 4. That means the only answer that I'm left with is n equal to negative 4. That means I'm sure that n is less than 0. You can put negative 4 here. Negative 4 is equal to modulus of let's say negative of negative 4 is equal to modulus of negative 4, that is 4 equal to 4. That means definitely I'm sure that my answer is equal to 4. Now there was an easy question and I just put so that you get relaxed and all that. So I suppose you've understood this question. I'm going to move forward to the next question, right? Okay, now it says that if n is not equal to 0, is modulus of n less than 4? Now what is he asking me? He's saying n is not equal to 0. Very important to write all the information in the mathematical form. n is not equal to 0, he's asking me is modulus of n less than 4. Okay, fine. Statement number 1, n square is greater than 16. That means either n is greater than 4 or n is less than negative 4. If n square is greater than 16, n can be 5, 6, 7, 8, 9, 10, or n can be negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, all those values, because I just have to say that what all values satisfy n square greater than 16. Yeah, negative 5 square is 25, which is greater than 16. So most of you would say, you know what, I'm getting a positive value, I'm getting a negative value, statement not sufficient. But just see what the question is asking you. Very important point. It's saying whether modulus of n is greater less than 4 or not. Whether modulus of n is less than 4 or not. Now over here, modulus of n, if n is greater than 4, modulus of n is greater than 4. And if n is less than negative 4, modulus of n is also greater than 4, because modulus of minus 5 is greater than 4, modulus of minus 6 is greater than 4, modulus of minus 7 is greater than 4. That means what? Yeah, I have an answer. Statement 1 is sufficient. It's giving me a definite answer. I hope you're understanding all that, right? Let's see statement number 2. Statement number 2, it says that 1 upon modulus of n is greater than n. Alright, now I can actually take this modulus of n to that side. Why? Because modulus of n is going to be positive every time. So n into modulus of n greater than 1. Now n into modulus of n is greater than 1. Am I sure that modulus of n is less than 4? You know what? N can be equal to 2. True. N can be equal to 6. So n can be equal to 2, which will actually satisfy this but gives me a no here. And n can be equal to 6, which can actually satisfy this and give me a, it gives me a yes there, and the other one gives me a no there. So that means statement 2 does not give me the answer, and my answer is answer option A. So hope you've understood. Now you must be starting getting the gist of how you're gonna do these questions. You know what? Do practice 20 questions and you'll be good at it. Better be, because you just gonna analyze what is there in the statement, and before you move to your answer statements, make sure that you know what you're planning to do, you know where you are, right? Okay, great. Alright, fine. Okay, let's see this question here now. Would be, now it says that modulus of x plus y is greater than modulus of x minus y, right? Now we can't actually interpret anything here. Let's actually see what we can do. So it says modulus of x plus y is greater than modulus of x minus y. Is that true or not, right? So again, we're gonna play with signs. We're not gonna play with anything as well, anything at all, right? So x plus y is, x is here, y is here, x plus y is here, and x minus y is here. So either you can play with numbers, you can play with signs. See, if x is positive, y is positive, x is negative, y is negative, x is positive, y is negative, x is negative, y is positive. It's just like those truth tables we used to do in computers, right? Okay, alright. So is modulus of x plus y greater than modulus of x minus y? So over here x plus y is gonna be a positive number, and over here x minus y is definitely gonna be lesser than x plus y, right? If both are positive, that means it's gonna be a lesser number than x minus y. That means over here this inequality would definitely hold. I'm pretty sure about that. So if x is negative, y is negative, that means modulus of x plus y would actually be as equal as modulus of x plus y, right? Whenever both are positive, whenever both are negative, doesn't matter to me. Well, when it comes to x minus y, again it's gonna be pretty much the same thing, because x will become negative, it will become negative x positive y, but a modulus of that. That means again this sign is gonna hold. You don't believe, you just take numbers, you just take 1 and 1, you know, you can take that, no problem there. Just take numbers. Now if x is positive and y is negative, let's say x is equal to 2 and y is equal to 1, right? So no problem there. So 2 minus 1 is 1, but 2 minus of minus number is gonna become a bigger number. That means over here I'm gonna have this sign, right? Isn't it? Similarly, if I say x is negative and y is positive, that means what? That means x is negative and y is positive. It's gonna be a negative number plus a positive number. Is it greater than a negative number negative of a positive number? So what I'm actually doing here is I am actually making this whole thing as negative, isn't it? It's negative of positive. That means this will actually add up and this will actually subtract, which means what? Which means that definitely there is gonna be a sign like this. So if both are positive or both are negative, this actually turns out to be a true thing. You know, modulus of x plus y is greater than modulus of x minus y. And if one of them is positive and one of them is negative, you know what? It turns the other way around. So this is what I have to actually say. So this is what my table says, and based on this information, what I'm gonna do is I just have to prove that is modulus of are both positive or both negative, or one of them is positive and one of them is negative, right? You could very well do this within a minute very easily in your exam. I was just trying to explain you, that's why it would take a little time. Now statement number 1 says that modulus of x is greater than modulus of y. You know what? If modulus of x is greater than modulus of y, x can be equal to 3, y can be equal to 2, x can be equal to 3, y can be equal to negative 2. Still this would hold true, but you know what? I'll get two different scenarios where I have this sign and I have this sign. That means statement 1 is not sufficient, isn't it? So now I can actually disprove very easily with numbers. Now it says that modulus of x minus y is less than modulus of x. Now modulus of x minus y is less than modulus of x. Now if both of the numbers are positive, then this would hold true, isn't it? Positive plus positive minus positive, that will actually hold true, isn't it? Similarly, if both the numbers are negative, that will again hold true pretty easily, because a modulus of a negative number, and this will again become a smaller number. X minus y will be smaller than x in terms of modulus value. That means still it will hold true. But if one of them is positive and other is negative, if one of them is positive and other is negative, let's take this scenario. The scenario says that x is positive and y is negative. X is positive and y is negative. So if x is positive and y is negative, that means it becomes a negative of a negative number, and this actually becomes bigger than modulus of x. That means this is not gonna hold true when it comes to this value, right? So that means what? That means that modulus of x is greater than modulus of x minus y will not hold true. Similarly, if you try x being negative and y being positive, this will also not hold true. That means I have only these two values satisfying. That means I'm sure that either both of them are positive or both of them are negative. That means every time I'm gonna have this sign, that means this will actually hold true every single time. That means what? I have my answer, and my answer is statement 2 gives me the answer. So the most important step in this is for you to analyze and understand the statement first before you actually move to the answer options. So before even moving to the answer options, you have to make sure that you make this kind of table, you understand this kind of you make this kind of analysis, and then you move to the options, so that before you move to the options, you know what you are doing, right? So I hope everyone has understood it, and I've solved a lot of problems as well. So I'll actually recommend you to go ahead and solve more and more problems, so that you get the hang of it. So no one can teach you inequalities. It's an art, it's not a science at all. There is no proper rules of that, but with practice you're gonna learn it, you're gonna understand it, and eventually you will get this, right? So alright, so this was about inequalities, right? So all these questions I've actually taken it from GMAT Club. I would actually thank them for that. And this is going to be my name, Pushpinder Gill, and this is going to be my email address. We can send me your valuable feedback, right? So thank you very much, and I hope you've understood inequalities. I'll be coming up with again another video on inequalities where I'll be solving some questions, and we'll be seeing some another approach of solving these kind of questions, right? So thank you very much, and see you next video.